and welcome back to my channel. My name is Jacob Jewett. After a long hiatus, I am back making these videos. I had some construction done on my house and unfortunately it took a lot longer than they said it would. Kind of hard to record when you got a lot of hammers going on and people beating on the roof and things like that. It takes a lot out of you. Anyway, moving on. Today we're going to cover the BIOS and the UEFI system. If you have watched my previous video, you know that I'm using the CompTIA A+ 22901 and 22902 study guide by Pearson IT. I put an image of that book and also the reference information on that book at the start of this video. And as I've said before, my videos are going to follow the chapter format of those books. Now I'm using those as a rough outline, but again, all the material in my videos will be separate from those books. The 22901 exam objectives focus heavily on hardware. Matter of fact, hardware is 34% of the overall score that you can get on that exam. So we want to pay attention to it very closely. Now, chapter 2 is going to cover the BIOS and the UEFI system and how they function in your computer and what they do for you in your computer, and how they're integral to the fact that your computer just will not run without the BIOS, and in newer systems without the UEFI system. We're going to explain what the BIOS is and how UEFI interfaces with that, and also what the BIOS does overall for you in your system and what the heck the BIOS is. So let's get on with it, and hopefully you learned something. If at any time you have questions, please feel free to leave a comment in the comment section of this video, and I will be more than happy to answer them for you. I also plan on, in future videos, having basically a QA session. I may even do a live stream. So with that in mind, let's continue on. Okay, so before we dig too much deeper into the BIOS and the UEFI system, I wanted to cover something called Jargon, or techno speak, or what we call LEET. And that's Jargon is what we use in the industry as a technician. The more you learn about our industry, the more jargon you learn, okay? And typically what jargon is, specifically in our industry, is technical speak that we speak to one another as a technician. So if you're speaking with another technician, you would hope that that technician understands what you're saying when you say RAM or VRAM or VLAN or vSAN, or you know, if you talk about fiber connects or fiber channels and stuff like that, you would expect the technician would understand what you're saying, and you could continue on. So a lot of the terms that we use in this industry can be quite long. For example, if we talk about random access memory, that can, if you're talking to someone, that's a long thing to say. But if you convert that down and you shorten it down to RAM, then another technician knows that when you say RAM, you're saying random access memory, and they'll understand what that is. Okay. However, if you're speaking to a lawyer and you say things like SSD or fiber connect or this or that, you know, that lawyer more than likely is not going to understand what the hell you're saying. Okay. They work in law all day. You work in the field of IT all day. So whereas you're expected to know these terms, a lawyer's not going to know these terms. Doesn't mean by any means that they're stupid. And I've met technicians that will automatically assume that a user is stupid because the user doesn't understand the term or doesn't understand how things work the way we understand things work. So hopefully through this video series, I do a better job of getting you to the level where you can speak geek, you can speak our jargon, but also at the same time explain it well enough that you can also convert the geek speak, the LEET, whatever you want to call it, to layman's terms for the end user, because at the end of the day, as a technician, that is your number one job, is to be able to communicate with your customer and get your customer to understand what you are trying to tell them. Okay, so let's get started first on some acronyms, and we're going to start with ROM. So ROM, okay, if you look at it, I've heard a lot of people say random things about this, but what it breaks down to is the true term of ROM is read-only memory. Okay, and you'll see that each letter of ROM breaks down to that. So we have read-only memory, and in this example, I have a read-only memory chip here, and what read-only memory is it's non-volatile memory, meaning if you take power away from it, it doesn't lose its information. It doesn't lose what's on it, okay? So a lot of times when a program is written on read-only memory, it's also known as firmware. And firmware is a program that is written and that does not get changed, okay? And there's some caveats to that, and you'll see very soon that we can change firmware, especially in newer technologies, but again, once it's written, is termed as read-only or firmware, because if the computer loses total power, that software, okay, or that program that is firmware is not lost, okay, whereas anything on RAM or random access memory would be lost. So as you see here, we have a 3-letter acronym here, and we know already that it stands for read-only memory. Another crazy thing that IT does is we like to use acronyms and expand upon them. So we'll not only have read-only memory, but we'll add a P to it, and we'll call this programmable read-only memory. And you saw me skip ahead a little bit, but programmable read-only memory, which is a PROM, okay? And if you look at the chip, I left the chip up there that I displayed before that is a read-only or a ROM. And in this slide, I've only included one additional thing, and that's because the only difference between a programmable read-only memory and a ROM, or just a pure ROM chip, is a pure ROM chip is sometimes called mask ROM. And the reason why it's called mask ROM is because the program or the firmware that is written on that ROM is permanent at the factory. They use like a light slide to burn the circuits onto the actual chip for the ROM, and so it's never changed. It will never change. It is what it is. So if you get a computer that has, if you got an older computer that had like a BIOS on it that had, it was on a ROM chip, the only way you could upgrade the firmware on that computer is to physically remove the chip from the board. And a lot of times manufacturers required you to send that chip back, and then they would send you out an updated chip that was also on a ROM, and you put it on there, onto your motherboard, okay? Well, sometimes people some technicians liked to make their own changes to the BIOS and have the BIOS do certain things that it wasn't meant to do out of the box. So, and also it was harder for manufacturers to make ROM because you had to literally, it is a physical process of programming the firmware onto the ROM. So they came up with an easier process, and this was called PROM. And this is where you had basically a ROM writer, okay? As you see down here, we have this ROM writer device, and you would get a chip that looked very similar to regular ROM, but it was PROM. And what it allowed you to do is allowed you to plug this chip into this device, and you would get blank chips, just like you go to the store and get blank CD-ROMs, okay? And you get blank chips from a supplier, you put it in this programmer, and you could write your own firmware or firmware from the manufacturer that they provided to you to this ROM chip or this PROM chip, and then put it into the motherboard and be just fine, and do your own little tweaks and stuff like that. You could see this could be somewhat of a process because it's, again, very physical, takes some time. And when you use a PROM chip, essentially what it's doing is it's literally using an extra charge on certain areas of the chip to burn the program in, meaning it literally burns the circuit. So it's either a on circuit or a 1 if we're talking about binary, or leaves, I'm sorry, it either creates a circuit, okay, or it burns the circuit away, creating a non-charge, okay? So in computers, a charge is described in binary as a 1, and a non-charge in binary is described as a 0. You can think of it as either off or on, okay? So in a PROM chip, the information is written on the chip and it is then permanent. Once you write a program on a PROM chip, if you messed up, or let's say this device that you have here that writes that information on that chip messed up, you just throw that chip away, put a new blank chip in there, and try again. Hopefully after correcting what you thought was the issue that caused you to get a failed chip. We once again also add on another letter to this, and this time we're going to add an E, and the E is going to be EEPROM, okay, otherwise known as erasable programmable read-only memory. So what ended up here actually is people got tired of using these read-only chips or these PROM chips once and then having to throw them away. It became very cost effective, okay? So it was not very cost effective at all. So they came out with this bright idea, and I use the term bright in a bit of a weird way because as you see, you have now a EEPROM chip, and you'll see that there's a little window here. If you follow my mouse, there's a little window here, and that's not glass. That window is not glass. And the reason why that window is not glass is actually crystal. And the reason why it's crystal is because glass does not allow UV light through. Okay, if you're driving in a car and you're going to LA or something like that, and the sun is hitting your arm through the car window, you're more likely not going to get sunburned because that glass is preventing the UV rays from getting to your arm. Whereas on a chip, when we use a thing called an EEPROM eraser down here that uses UV light to erase this chip, we want UV light to be able to get to the chip. And so if you look right here, you'll see under this window is a actual chip, and on it, it has special chemicals. So what happens is you program this chip the same way that you programmed a PROM chip. You get a PROM or a chip programmer, and you program the chip the same way you would a PROM chip. Okay. However, let's say you screw up. Let's say you mess up. Where you used to throw the PROM chip away, this one, you're able to take this chip and put it into the drawer of this EEPROM eraser, and you have the window on the top, and then you'll close this drawer. You'll set this timer for 5 to 15 minutes, and the high intensity UV light that's actually in this box will beam on that chip for 5 to 15 minutes. And in that process, it'll break down the chemical and basically erase the chip. So it's almost like brand new. There is a limit to how many times you can do this, and it varies chip to chip, but you can get away with it. Now, after you're done programming this chip, a lot of times you'll see that these chips have like a white label that get placed over them, and you'll see that in my later slides. But basically, people put that white label over that chip to make sure that no errant UV light gets through. For example, in the studio here, I have lights around me, and each light gives off its own UV light. Most lights do, okay, especially like fluorescent lights. And although that type of light, since it's not as high intensity as a UV specific light, might take longer time to degrade the program on this EEPROM, but eventually it will. So the best idea is to cover this up with a label, and you'll see that that is actually a major practice, that they will cover this up. Now, we've come out with newer technologies, so therefore the likeliness of you seeing one of these chips, very, very unlikely, and you won't really see them unless you're doing like a project board, like working with like an Arduino or a Raspberry Pi or something like that. You're not going to typically see these chips, especially in today's computers. The reason why I'm showing you this is to show you how our acronyms change, and also so you can kind of get an idea of some of the history. All these chips that I've shown you so far, and the one that I'm about to show you, have all been used at one point or another for the BIOS program, okay? So we do it again, and we add another E to it, and eventually I'll learn how to not to go backwards in my slide and mess up my whole presentation, but who cares? But now we have what we call EEPROM. We just added another E to it, and that stands for electronically erasable, programmable, read-only memory. And so what we did is this time we got rid of the UV light process. We said, okay, we're tired of buying another component to either write to the chip or to erase the chip. Let's come out with a chip that we can write and read from and program and erase and all that stuff without having to remove it from the computer. And so we came up with the EEPROM, the 2 E's, PROM chip, and that's typically what's used in today's computers as far as a BIOS. And if you look at this, it's characteristic by the fact that it is soldered to the board now. Now, some boards you'll see that this is actually in a socket and it can still be removable. But a lot of boards, especially ones that have like a backup, which this particular board does, you'll see that they got a dual BIOS setup. So there's, you'll see the main BIOS and then you'll see the backup BIOS. Okay, so if you have a motherboard that has that kind of setup, more times than not, they'll be soldered directly to the board and they won't be removable because they figure you got a backup, you can recover from this. Okay, so those are the chips again that we use nowadays, and that's the type of RAM or the type of ROM or that we now write firmware onto as this EEPROM. And we do that so that we can easily flash the ROM or flash the BIOS and rewrite firmware or updated firmware to the BIOS. And we'll learn, very shortly on how to flash the BIOS. But again, a little history doesn't hurt anyone. So the next thing that we're going to cover is the BIOS. Now the BIOS, very easily broken down, stands for Basic Input Output System. Okay, so what this does is it's a piece of firmware that resides on an EEPROM chip nowadays. Used to reside on a ROM chip, but it is the first thing that your computer looks at when you power it on. Okay, the BIOS gives your computer the instructions it needs to get to your eventually get to your operating system. So it contains all the basic drivers to activate your keyboard, to activate your video, to get you the basic stuff needed, and to provide the basic information needed to your system to boot up. Now, when you boot up, are you done with the BIOS? No, you're not. The BIOS is actually written to your RAM, and as your system boots and as more drivers are loaded, they're actually loaded to RAM, or random access memory, on your computer, and that makes up your BIOS, or your basic your basic input-output system, and therefore your operating system knows what hardware is what and where it is, and so does your computer. Your CPU knows through addresses where everything is on your computer and how to communicate with it, what channels to communicate with it on. I'm getting a little bit deeper than I need to get right now, but you just need to understand that that's what the BIOS is for. It is the first thing that your computer kicks in as soon as you hit the power button. Okay, and we'll describe that process a little bit more detail very soon. This right here, this screen here, you see is the BIOS program. Okay, it can be quite confusing sometimes. On the top, you'll see Phoenix Award BIOS and a CMOS utility setup utility. If I could talk straight here. But all basic BIOS systems will have this look and feel to it. There's two major ones, and the major one right now is Phoenix, and they're the primary one. There's AM BIOS, and then there's Award BIOS and stuff like that. Phoenix bought out Award BIOS, so they're both the same company now. It can get quite confusing. As you get into IT, you'll learn more about the BIOS, and you'll get deeper into understanding what's what. But for the most part, the layout you'll see here is very similar. It doesn't matter what BIOS you go into. Typically, you'll see these few layouts I'm about to show you. This primary one here that you see is very textual driven. You have to understand that the BIOS is a 16-bit program, meaning it's very limited on what it can display. So in the BIOS, you're typically not going to be able to use a mouse. You'll have to use like the keyboard up and down arrows and plus minus symbols to activate, deactivate things, or page up, page down to navigate to different pages of the BIOS and things like that. You're typically not going to be able to use a mouse because it's just not that vibrant of a system. It is the reason why it is a 16-bit program is because the BIOS in the name, basic input-output system, is meant to be very backwards compatible, meaning you can go to the earliest legacy device and hopefully the BIOS is able to utilize that, because there's a standard that is published that every device must at least conform to this lowest standard. So if you boot the system, the BIOS will display. Some people go, I have a 64-bit system. Everything in my computer is 64 bits. You know, the software, the processor, everything, 64 bits. No, super fast. Well, they're full of crap, because every BIOS and every computer is 16 bits. Okay? So we start off with 16 bits, then we move up to 32, and then up to 64. And basically, a 64-bit operating system is backwards compatible, usually with 32-bit, and if they allow you, down to 16-bit. But anyway, so you'll see some main screens. Now, you need to get yourself familiar with the screens of the BIOS. It's very important that you get yourself familiar with these screens, because you're going to have to navigate with them quite a bit. So as I move myself to the side, you will see that all the BIOSes start up into a main screen. So we have this main screen, and you can see that there's a lot of subsections. In the BIOS, when you see an arrow next to a menu item, that means that there's a sub-menu or a subset of settings that you have to set on that. You'll see in this BIOS program, there's only 4 items which do not have an arrow next to them. Meaning if you click these, if you activate these by navigating to them with the arrows and hitting enter, they'll do exactly what they say. For example, save setup default or load setup defaults, set password, save exit setup, exit without saving. So those are pretty self-explanatory. The main ones that you'll want to pay attention to is going to be load setup defaults and save and exit setup. If you go through the BIOS and you do your configuration changes, and let's say you spend a while in the BIOS and you're doing this, and you just, you made a change, you hit save and exit setup, you went to boot up your computer, and your computer looks at you funny and flips you the bird. Basically won't boot, won't do anything. You may start freaking out. Well, what do I do now? You just go back into the BIOS and you use load setup defaults. And what that'll do is that will clear the CMOS, which we'll talk about here shortly. That will clear the CMOS of all the settings and get you back to the default of when the computer was shipped to you or when it left the factory. So all the settings on the computer will go back to default, and you can go back and you can tinker and mess up again and load the setup defaults again if you want to or whatever. The times that you're going to use exit without saving is when you go into the BIOS after, let's say, you've made configuration changes, and so you go back into the BIOS, you make an additional configuration change, and then you decide, oh, well, I didn't want that change. Then you exit without saving, and that'll leave the current settings in place. However, if you save and exit setup, those settings that you changed are then written to the CMOS, and they become semi-permanent, meaning those will be the settings you run off of, and the only way that you can reset them or get them cleared out is to either go back into your BIOS and manually change the setting yourself, or go back into your BIOS and say load setup defaults and basically start over. It is highly suggested as a technician that you have a notebook with you, sometimes preferably pen and paper, to notate the settings that you change, so that if you ever have to go back and change something, you know what settings you made and what you changed in the system. So that, let's say on Monday you make certain changes to the BIOS and it works fine, everything works on the system. On Wednesday you go back into the BIOS, you make a change, you restart the computer, and it flips you the bird and it's not going anywhere. Hopefully you've made notes and you know what you changed. What's different between Monday's settings and the settings you made on Wednesday. So let's go through some of the screens so you can see what we have here. So we have the standard CMOS features, which is going to be your time. It's going to be the date and time. It's going to be, this is an older BIOS program, so you will see that the name up top changed. I just grabbed random screenshots so I could show you the differences between BIOSes. But in this standard CMOS features, you're going to see these typical changes within this screen. So you're going to see master slave, if you got floppy drive, if you got that set, if you got floppy 3 mode support, if you want the computer to halt, if it notices a keyboard error, for example, the keyboard isn't plugged in, or maybe someone spilt water on the keyboard and it shorted out, the BIOS is going to be able to notice when it's having problems communicating, and will stop and say, hey, I can't see a keyboard, hit F1 to continue. Well, you can't hit F1 until you got a keyboard plugged in, so it works pretty well. The next screen we're going to see here is advanced BIOS features, and that was the next item that you saw on the first screen. And you'll see that we get deeper into things. For example, on this particular BIOS, we can change the VGA output connect. Like, we can decide, do we want it to go through HDMI, or do we want it to go through a expansion card or through the built-on video on the computer. We can do that. UMA frame buffer size, we can change that. Usually auto is the best place to leave it. Virtualization technology, you'll see here that I underlined it. And the reason why I underlined it is because you'll see throughout this course that I will use virtualization to show you certain things. Well, you practicing and studying for the A+ test can also use virtualization, and I'll show you how to do that. But there's a setting in your BIOS that you need to enable, and it's disabled by default, but you need to enable virtualization so you can use virtualization technology. If you do not enable this setting in your BIOS or your UEFI system, more likely virtualization or being able to use VirtualBox or VMware Workstation on your computer is not going to work properly because the processor or the settings for the processor are not set to allow it. So again, under advanced BIOS features, if you're using the old style BIOS, it's going to be under virtualization. This particular BIOS is from an AMD computer, so you'll see that you got AMD's special technology here it's old in today's standards, but they got a setting there. You got your hard disk boot priority. If you press enter, it'll bring up another menu and actually give you options on what device you want to boot first. If you want it to boot from, for example, onboard NIC or a network card, or you want it to boot from a floppy or a USB drive, this is where you're going to change that, is under press enter for the boot priority. You can also set your first boot device, so on and so forth. Again, from BIOS to BIOS, a lot of times this changes. The thing that you have to understand for the A+ exam is where these settings typically are. So, you know, under standard CMOS features, that's where you're going to set the time. Under advanced BIOS features, that's where you're going to set additional features, for example, boot priority and stuff like that. Under integrated peripherals, that's where you're going to go and set settings for things that are soldered to the motherboard. For example, if the motherboard has a video card that is actually built into the motherboard, you would go to integrated peripherals to either enable it or disable it. If you want to, for example, add your own audio card or you know, additional modem or something. For example, if it's got a built-in NIC or a network card in it, if it's got its own NIC, you may want to disable that NIC so you can add a faster NIC into the board. That's where you're going to find these settings, is under integrated peripherals. Next, we got security chip configuration. If you have a TPM chip, this is where you'll set that up in the older BIOS. Security in the older BIOS systems is very flimsy and not very good, and I'll show you why here in a second. But again, it's not the best, so I would stay away from trying to set any kind of security in the BIOS. It's, you know, it's generally useless. Here we have power management setup. That, again, all these sub items are from the main screen, and this is where you would set up the kind of system, basically power saving settings that you would use on your computer or that your operating system would understand. Typically, you have to look at the operating system that you're using, whether it's Windows or Ubuntu or I'm not going to say Apple here because Apple won't run on a PC. But if you're using like CentOS or something like that, sometimes they have very specific settings that they use for power saving features. And so if you use anything but what it says, sometimes those power saving features won't work. But as you see here, you can set those up within the BIOS. And this, for example, is set up for S1, which is set up for suspend, standby, or off state of the system. Next, we have the PNP PCI configurations. Now, this screen used to be very integral to how you use the computer. For example, if you added that additional network interface controller card, or NIC, in the old days when we did that, we used to add it into what was called an ISA slot. And when we did that, we had to set addresses and interrupts, or RQs, and RMAs and DMAs. I said RMAs, but it's DMAs and all that stuff, COM ports and things like that. We had to manually set those in the BIOS so that the computer knew where those cards were, where they were addressed on the bus system. You'll learn what a bus is here in following chapters. But yeah, we used to have to address those and do it manually in order for the system to understand where it was and how to get to it. Think of it almost as like writing an address on an envelope and sending it off for the mail carrier to take it to the right house. It's very, very much similar in that form. It's basically, your processor is a mail carrier and it's trying to get to the right house. There's some layman's explanation for you. Okay, the great thing is this has become almost an area that we don't have to touch anymore, because we have now what's called PNP, or plug and play. And basically every operating system since Microsoft Windows 98 Service Second Edition, so Windows 98 Second Edition, introduced PNP, okay, plug and play. Basically, you take adapter cards now, or expansion cards now, and you plug them into your computer, and your computer automatically knows what it is by if it's a PCI card, typically it knows by what slot that card is plugged into, what addresses it needs to assign to it. So therefore, we hardly, if ever, go into this anymore. So it's one of those leftover legacy items, but it's still there, and you need to be aware that it exists. PC health status. PC health status is where you would go to find out the voltages that are being applied to certain areas of your computer. Most power supplies, especially anything nowadays or anything after the 2000s really, are somewhat smart in the way that the motherboard and the power supply can work together, and the motherboard can tell the power supply, hey, this is how much power I need over here, give it to me, and it does. It supplies the power. And you can also see through the motherboard utility what voltages are being used where, like the CPU, what kind of voltage that's using, so on and so forth. CPU temperature, system temperature, CPU fan speed. Why would you want to know the fan speed? Easy answer. You would want to know the fan speed because if the fan is stopped, your CPU is not getting cooled, and therefore it's going to overheat. And now in these days, if you don't have a fan or water cooling or something on that CPU is going to burn up real quick. They require cooling. So just like I said before, where if your computer boots up and it doesn't notice a keyboard, it will stop the computer in its tracks until you get a keyboard connected. The same thing is true for when you have a CPU fan that stops spinning. If the BIOS sees the CPU fan is at 0 and you haven't told it to ignore it, it will stop. It will say, CPU fan is not attached. CPU fan is not running. Check it. Okay, it tries to protect you as best as it can. The next thing, frequency voltage control. This is in newer computers, in particular computers, and well, it's in older computers too, but it's in computers that allow you to overclock. Okay, basically get the processor to do more calculations per second than it was actually designed to do. So for example, if you buy a processor that says that it can handle 3.2 gigahertz per core clock or whatever, you can typically sometimes overclock those to 4.2 gigahertz or sometimes even higher. I've known some people to actually clock like a 3.2 to like a 4.5. The problem with overclocking is it does eventually wear out the processor faster, so it kind of decreases the life of the processor. However, if you want to do that and you know what you're doing, you can go here and do those changes. As you see here, this is obviously from older computer. It's talking about bus frequency and so on and so forth. So we don't typically speak in those terms anymore. Now we typically talk about clock cycles and multipliers and stuff like that. And you'll see that in newer BIOSes. Before I continue on, the one thing I meant to point out before and that I didn't is down at the bottom of the screen, you'll see that it gives you a key of what kind of navigation you can use within the program. And if I go up, you'll see that this does not change. These are all different BIOS programs, and yet those very seldomly change. Okay. Moving on, this is another Phoenix BIOS utility setup utility. Typically in the higher end computers, they would use this version of the BIOS. But again, it's the only difference between this and the last one that you saw is it has the tabs up top. Now you can't use your mouse on this and just click to the tabs. The tabs on top you can navigate to using your arrow keys. And they call these tabs, I'm calling them tabs, but they said menu items. So if you look at the bottom or the footer of this program, it says select menu item, use your left or right keyboard key, and that allows you to navigate through advanced security and boot. And you're going to see that the difference between this one and the previous one is the startup screen is your main. Okay, so there is no like startup screen where you select individual items to get in. So when you saw the general CMOS settings before, this is the same thing here. It's just named main now. If we go through it, we got advanced, and then again the same rule applies here as it did in the previous BIOS settings I showed you. If you see an arrow next to it, there's more to that item than just that single item. So you see advanced BIOS features, advanced chipset features, a lot of this stuff all the same, just a different view of it. So if I'll go through it a little bit faster, but if you really want to see where these things are, go ahead and pause the video and examine it, because they're going to, in the A+ exam, they will show you a BIOS screen and say, where would you find this? Like, where is this more likely to be found? And you got to choose the best answer. So it's always good to understand where things are in different versions of BIOSes. If you want to see more versions of BIOSes than what I've provided here, just do a Google search for BIOS, and you'll see, just like, especially like an image search, you'll see a ton of them. Also, as I've stated before, it does not hurt to go to like a nickel dime store or a secondhand store and pick up old computers. You can go to Goodwill and pick up old computers for just pennies on the dollar, and those work as good test beds to learn what you need to know for the A+ exam. And the more hands-on you get, the better it is. So the next thing that we're going to talk about is the UEFI system. otherwise known as the Unified Extensible Firmware Interface. All computers that have a UEFI system will also have a BIOS for backwards compatibility and legacy. Not only that, the BIOS, even if there's a UEFI firmware interface existing on the machine, the BIOS is still the first thing that boots up the computer. The BIOS will boot up the computer and then kick off to the UEFI system to do the more advanced features. For example, in newer motherboards, the UEFI system can control fan speeds on the computer. It can control overclocking on the computer. It can control a lot of things. Not only that, it makes it a lot easier to flash the BIOS and things like that, because a lot of times these UEFI systems will have actually network interfaces, software or drivers built into them, so that you can actually communicate with the internet and download drivers from the internet, or and download firmware for the BIOS from the internet directly without even booting up the computer. Makes it a lot easier to do a lot of things. For example, I've seen the UEFI system used on a motherboard without a CPU plugged into it. So the idea is being that you can have no RAM, no CPU, no nothing connected to the motherboard, and actually boot up into this UEFI system and be able to flash your BIOS and stuff like that, get up to date before you even connect a processor to it. It's quite cool. So the examples I'm going to show you are motherboard manufacturers' UEFI systems, and these typically are stored on a chip on the motherboard in the same way that the BIOS is. Now, the BIOS chip is typically a lot smaller as in capacity size, but chips that support UEFI systems are much bigger. Sometimes they can get as big as they want. There's no real limitation on this, but it allows the motherboard manufacturer to do a lot more with. What the A+ exam is going to want you to know is, especially in the UEFI system, is they're going to want you to know where the health information is for the computer. So be very aware of that. Now, lucky for you, most UEFI systems made by motherboard manufacturers will typically have the first page as being like the health status, or they'll, like on this ASRock, you'll see that they have the actual call out for it up top here where it says hardware monitor. So just be aware of where those things are. So we've talked about the chips that the BIOS exists on, the BIOS program, and we've talked about UEFI. Well, how does this all work together? How does everything function? Now, this is an area where I get a little uptight, or I guess a little out of sorts on, and that's basically because most publications I've seen, for example, from Pluralsight and even from this book that we're following, they state that the BIOS and the CMOS are basically the same chip. Like, they are one and the same. The BIOS exists on the CMOS. That is false. That is false by a far margin. They are actually separate chips. In older motherboards, the BIOS existed on one chip, and the CMOS was another chip. It was also known as what's called the RTC NV RAM. Okay, and you'll see that there. Basically, RTC stands for real-time clock. Okay, it's what keeps track of all the time, date and time on your computer, and also is responsible for sending the pulse in older computers to the motherboard to keep track of clock and communication cycles. So that was a real-time clock, and it used to work with, I think it still does, works with a crystal to precisely time that pulse. So real-time clock and what's called NVRAM. And this is a bit of a misnomer as well. NVRAM stands for non-volatile RAM, or random access memory. And why that's a misnomer, and you'll see that in the later on, and I kind of go over it time and time again, is non-volatile means that if you take power away, information is not lost. Okay. The BIOS program on a PROM or EEPROM chip is non-volatile, and it's non-volatile because you can kill power and it's fine. It doesn't hurt it. It doesn't lose any information. When something's called volatile, it means that it loses that information when power is lost. If all power is lost, what's on that chip is gone. RAM is a prime example. So when you boot your computer, everything gets loaded to RAM as far as like the operating system and the programs you use. They don't run on the hard drive, they run in RAM. That's why you have to have a lot of RAM, depending on your operating system, what programs you're using. That very much dictates how much RAM you use. So therefore, everything's loaded into RAM. RAM is faster than a hard drive, so therefore the CPU can use it a lot faster, and it's random access. If you kill the power to your computer, everything in RAM is gone. If it's not written to the hard drive, it is gone. It doesn't exist anymore. You cannot recover it. There's no going back. Okay, so therefore it's volatile. Okay, so volatile versus non-volatile. Volatile, lost when power is lost. Non-volatile, stays when power is lost. Does not affect it at all. Okay, so this is how things work. So you see that I call this out as two separate things. We have EEPROM and we have CMOS. The BIOS and the UEFI systems exist on EEPROM. Some more advanced UEFI systems, that's a tongue twister for me, will also have portions of it on the hard drive of the computer. So if you boot the computer and you see in your operating system, you see reserved space on the hard drive, usually that's a software version of UEFI or some subcomponents of UEFI. So being that it's a more advanced system, typically it can spin the hard drive up and get more information and provide a nice fluid environment for you. This is a basic layout of how a logical, I guess you could say, layout of how the BIOS subsystem works. So the CMOS, we haven't described that yet, and let's go over that quickly. CMOS stands for a complementary metal oxide semiconductor, and the CMOS is a chip, and what it does is it stores the information for your BIOS, the changes that you make in your BIOS on this chip. Okay, and because the BIOS, as we said before, is firmware and never changes. Well, if it's firmware and never changes and it exists on an EEPROM chip, how is it keeping our changes at all? How is that information kept if it's on a read-only chip? It only exists there, so therefore, when we turn off the computer, it's going to go back to defaults. Well, what prevents us from doing this is the CMOS. And the CMOS is responsible for storing the changes that are made in the BIOS program. That's why a lot of times that you'll see the BIOS program will say CMOS program or CMOS setup utility or something like that. Because essentially what you're doing is you're sitting on top of the default firmware okay, or the default program, where the default settings are, okay, and you're making changes to the defaults. Well, on the BIOS, the changes aren't being made. The BIOS is going about its merry way, saying, this is how I am, I'm not going to change my ways, I'm stuck in my ways, go flip yourself, whatever. Okay, the CMOS is standing there, hey guy, I'll take your changes. And guess what? When you turn on the computer again, I'm going to tell the BIOS where he can stick it. Okay, so he's going to, basically the CMOS is going to sit on top of the firmware with the changes. So if you enable something, the BIOS firmware is going to load first, and then it's going to look at the CMOS for what changes have been made and pass those through. Okay, for example, if the default setup of the BIOS is to boot from CD-ROM drive, but on your CMOS setup program, you set it up and said, no, I want you to boot from the hard drive first. When the computer boots, it's going to load the main program, the firmware, and then it's going to load the CMOS, and it's going to go off the CMOS settings saying, oh, he wants to boot from the hard drive, not the CD-ROM drive. Even though that's the default, we're going to overlook that. This is going to sit on top of it, so therefore it's going to go with the setting that you set. Okay. In this picture, I found a picture where you have your BIOS chip here. Okay, this is this could either be an EEPROM. It looks like this chip was made in 1999. That could be the copyright of the BIOS, or that could be the actual manufacturing time of the BIOS chip or the EEPROM. If it's an EEPROM, it could also be a PROM. As you see, it's removable. Sometimes these were also EEPROMs, and they made them removable. So like if you were flashing the BIOS and the power went out in your house or your apartment or wherever you live, and it messed up the flash of the BIOS, like the program did not get written to the BIOS, well, it erases the BIOS before it writes the program. So if it didn't fully write the new program to the BIOS, you just bricked your motherboard. Okay, and bricking is what we call in the IT industry when you've basically made your motherboard to where it will no longer function. It's just gonna, if you press the power button, it's gonna look at you funny, light up some lights, and just kind of sit there. It won't do anything for you. So therefore, they made these chips removable, so if you bricked your motherboard because of a bad load, you could call the manufacturer, get them to send you out a new chip, you put it in place, and you go about your merry way. Companies like Gigabyte got around this by providing two BIOS. You saw in the earlier example the dual BIOS picture. That's dual BIOS because basically they wanted to get away with not having to send users, replacement BIOS every time they brick their motherboard. So in this picture, again, you see the BIOS chip, and right next to it, you see the CMOS chip. Okay. In newer computers, the CMOS chip, or now it's called it's an integrated chip, called the RTC NV RAM, and that's now included in the chipset of the computer. And we haven't covered that yet, but we'll describe it later. Basically what they did is they cleaned up the motherboard, took a lot of small components and put it into one chip on the motherboard, basically just integrating a lot of features into one single chip. And I'll explain that in the next chapter, which is when we cover motherboards. But you'll see the CMOS here. That is the complementary metal oxide semiconductor. Okay, so here we are again to the layered approach that I showed you before. And if you look at the way I have this set up, you have the BIOS UEFI Subsystem firmware program, which is the program, as the name states, firmware. It never changes unless you flash it, unless you like erase it completely and restore it with a different program from the manufacturer. But once it's on the chip, it's firmware. It does not change. So the settings, or the default settings from this, get passed down and get covered up by the CMOS, or the RT NV RAM. Okay, and this holds the adjustments or time on the computer, and it also keeps track of it keeps track of any changes that you've made to the BIOS. That then calls out expansion board BIOSes, and the reason why we say expansion board BIOSes is every computer component that is an expansion card that you put on the computer, for example, video card, NIC card, RAID controller, anything like that, has its own BIOS on board. Okay, that's part of the process of what we called earlier P&P, or plug and play. It has its basic information, its basic input-output system on the board, and it communicates with the motherboard's BIOS and gathers together and gets stored in RAM. Okay, once it's stored in RAM, it then kicks off what's called a bootstrap, or the MBR, master boot record. Okay, and then loads your operating system. Now the settings on this are controlled by, are not controlled, but are saved by a coin battery on your computer, on your computer's motherboard. It's called the CR2032 battery. That's the most common battery used. This is a lithium battery, and what it does is it provides just enough power to this chip, or to the CMOS chip, to keep the information there. Remember, I said it was a misnomer that this is called NV RAM, or non-volatile RAM. The reason why they call it non-volatile RAM is because it requires so little power to keep the information on there that it essentially is non-volatile. Okay, it essentially will not lose the information. For example, this battery that's on the motherboard will last typically 3 to 4 years without being changed. So 3 or 4 years of information being kept on this chip without it losing it, that's pretty non-volatile. Where it becomes volatile is if you remove the jumper that supplies the battery power to the CMOS or the NV RAM. When you do that, it cuts the power. All settings are lost on that chip. All time is reset, so it does not keep time. It will reset back to the manufacture date of the CMOS, or sorry, it'll reset back to the manufacture date of the BIOS that you're using, or the UEFI system that you're using. So if that UEFI system was published on such and such date, it'll go back to that date. A lot of times when a computer boots up and has an error saying low battery power, it's typically this battery right here, and it's these settings have been lost and you have to reset them. Another good reason to have a notebook and keep notes on what settings you have. Okay. The other good reason is if anyone has physical access to this computer, or any computer, and the reason why I said a password on the BIOS is no good, the reason why I said that is because all you have to do to reset the password on a BIOS, or to reset settings on a BIOS, is to literally pull a jumper, or even remove the battery from the motherboard while the motherboard is not powered. If there's no power to the computer, and if there's no battery on the computer, all settings, all changes are going to be lost. Is your BIOS lost? No, it's not. Your BIOS is not lost because it's firmware. It will always be there unless you flash it and mess up and brick the computer. Again, call the manufacturer, get a replacement BIOS. Okay, but Yeah, so here's some more images of BIOSes, and you see here in this image the picture of that battery that I was talking about, the CR2032. You'll see that battery also over here, and it's not in the rest of the pictures, but here's an old BIOS when we were using PROM chips or EEPROM chips. So this label here, although I don't believe it is in this picture, on an EEPROM chip, like an original EEPROM chip with a crystal window, this label would be covering that window, protecting that program on that chip. This can also be EEPROM. This can also be just a regular ROM chip. It isn't in this case. I believe this is a EEPROM, the 2 E's, EEPROM chip, where you can electronically reprogram the BIOS. However, this one is removable. Obviously, if you have a flash of the BIOS that fails, you want to be able to easily remove this and get the manufacturer to send you out another one. Same down here. You'll see here I showed the jumper here for the BIOS or the CMOS reset, and basically CMOS reset, all you're doing when you remove this jumper or put it on this jumper pin right here, is you're shorting out the battery, or you're shorting out the connection to the CMOS, which is right here, and therefore no battery power is being supplied, and you're clearing the CMOS. So there's different ways of clearing the CMOS. There's basically 3 different ways of clearing the CMOS, or RTC in NV RAM. The 3 ways of doing it. 1, you can remove the battery and all power to the computer. Okay, so you take a small screwdriver, you remove the battery, flathead screwdriver, you remove the battery, and you make sure that there is no power going to the computer. That's one way to clear the CMOS. Okay, second way to clear the CMOS is to move that jumper. Here you see that there's one jumper. You just remove the jumper, it removes power to the CMOS and clears it. Same here, you remove this jumper, it clears it. Both first options, whether you remove the battery or you move the jumper, both options require that no power be supplied to the computer. Some newer computers will actually have a button that you can push, and it doesn't matter whether the power is on the computer or not, it will still clear the CMOS. They've made that a little bit easier for you. But so I guess there's 4 ways. But and then finally, the third way of clearing the CMOS is going into the BIOS or into the CMOS setup program, BIOS/CMOS setup program, and selecting that option, load setup defaults. Essentially, when you load setup defaults, all it's doing is clearing the CMOS, because the setup defaults are what's burnt into that BIOS program. So therefore, that's all that instruction's doing, is saying, hey, clear the CMOS. Okay, so again, we'll go with 4 ways to clear it on newer systems. The 3 main ways is to use the jumper, remove the battery, or load setup defaults. The 4th way on newer systems, on newer aftermarket systems, is to actually press the BIOS reset button on the motherboard or on the back plate. So that again, that's in newer systems. Now finally, the last thing I'm going to take you through on these slides is what's called the POST. Okay, this is the final acronym of for right now. And POST stands for Power On Self-Test. So when you power on your computer, one of the first things it does is it wakes up the BIOS. Okay, it reads the BIOS and loads it to RAM. But in this process, it's doing POST. Okay, So if you watch a lot of other YouTubers, for example, Jay's 2 Cents or Bitwit or any of those guys, a lot of times when they build new computers and they power it on the first time, they're like, post, come on, post, come on, post. And the reason why they're doing that is because if post fails, the computer will not boot. Okay, and basically what post does is it tests all the major subsystems before it allows it to load what's called the bootstrap and move on to the boot process. So here we have post, and it happens during this whole building of the BIOS that I told you about. So I told you about the firmware, I told you about the CMOS, the real-time clock, and NV, RAM, and expansion card BIOSes and all that stuff. While all this stuff is getting loaded to RAM, post is happening. So it's getting that it's testing your settings and making sure that it's in a format that is going to allow the system to boot. Okay, so one of the first things that the post does is it tests the RAM. It tests to see if the CPU is present. During this process, it will, on newer motherboards, it will actually display codes on the motherboard. They have, like, on most new computers, as far as like aftermarket computers, not Dell, not HP, not anything that you buy at CompTIA, not CompTIA, sorry. Not anything that you buy at Best Buy, but anything that you buy is like aftermarket, like custom motherboards and stuff like that. Most of them include a digital display on them, which is basically a post readout. When you boot your computer, you'll see a whole bunch of characters go across that digital readout, and that's basically testing components on the motherboard. And what happens is if your motherboard hangs up or post fails, it will display a character on that digital readout, and that character will directly relate to a call out in the motherboard's owner's manual. Okay, so it'll tell you what's wrong with that, what's happening, what's stopping it from booting. So previous to digital readouts, and something that's still used on even shelf computers, so computers that you would buy from Best Buy or Walmart or anything off the shelf. Okay, off the shelf is a term that we use for things that you buy at, like, at retailers. Okay, so these computers, basically, they do a post as well, and older computers do a post. And what will happen is you'll hear the computer beep and do beeping sounds. And if you hear beep codes, usually prolonged beeping sounds, like almost like a Morse code kind of sound, like beep, 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 beep. Okay, those are actual codes that if you listen to it and you get out your motherboard's manufacturer owner's guide, it will have those codes in that guide and tell you what's wrong. Is memory not properly seated? Is the CPU not responding? Is the video adapter not present? You know, like in your BIOS firmware, in your CMOS program, you set on that program, hey, I want you to use an expansion card or a video card that I plugged into the motherboard. Well, if that video card is not responding, the BIOS will fail, because it says, oh, you want me to call out a card, I need video, and if I can't get video, I'm just going to beep at you a whole bunch of times and tell you, hey, I can't boot up. Or, you know, if you overclock and you overclock the CPU and you do it in a wrong setting, or too high of a setting, or not enough voltage or something like that, typically you won't see a video display on your computer. Like when you boot the computer, you won't see the startup screens. Your computer will constantly reboot. I've also seen computers constantly reboot from like power supplies that are just worn out. They're not providing enough power, so therefore the computer, when it starts to ramp up and need more power, it will fail and reboot and reboot and reboot. And most of the time it will display, if you got a digital readout on the motherboard, it will display the code that is related to that problem, especially if the manufacturer is good at calling out codes. Or it'll beep. It'll give you an audible beep of problems that it knows that it could be. Okay, these are all diagnostic tools that are very useful, and they're all part of post, or otherwise known as power on self-test. If your post succeeds, okay, to the point that you get like a video display, but it still fails, it'll typically tell you, hey, guess what? I was able to load this far, but there's a problem. Hit F1 to continue to go into BIOS, or on some motherboards it's F2, or it could be delete. Hit those keys to get into the BIOS. Example of this would be the keyboard missing. Okay, keyboard's not connected. It'll say like hit F1 to continue. Well, you gotta connect the keyboard, right? So those are all post commands. That is a subroutine that's written into the BIOS program and is part of the BIOS process. You start up the computer, BIOS loads, it runs post. At the end of post, it'll typically give you the option to load into the BIOS and change settings. So what I got here is I got a virtual machine that I've started up so I can show you the BIOS program or CMOS interface. Now this is not a physical machine, this is a virtual machine, meaning it exists in software only. The great thing about virtual machines is you can basically test everything on them and not have a bunch of hardware around. And fortunately, one of the things that I can test and kind of show you is the BIOS in this operating system. So I'm going to go ahead and click on here, and we're going to restart this program. It might take me a couple times. Did it the first time here. So what you see here is even in the virtual environment, I do have access to a Phoenix BIOS setup utility. And you're going to see that on the main screen, we can, in fact, change the time. We can change the date. And we can also apply legacy floppy. We can do disk B. Disk B has never been used as long as I've been in the IT industry. It may have been used when I first started out, but certainly not since then. I don't have any virtual drives connected to this VM, so therefore this is going to probably show up empty right now. Most of the time they're set on auto, so they should detect hard drives. If there was a hard drive there, you would see the settings for the hard drive displayed down below here. I just hit the exit key to get back to main. I can go, again, the same rule applies, that the arrow next, or the arrow next to the item indicates that there's more to that item. So if I go here to legacy diskette B, when I hit enter, I'm just going to get the selections for that one item. Whereas if I go back by hitting escape and go to primary master, there's more settings there. So when I hit that, you're going to see I have more options. It takes me to another screen. Okay, so we can see our system memory and our extended memory. The system memory, the 640 kilobytes there, that system memory is typically the BIOS. That's the size of the BIOS. That's what exists on the system if you did not include additional RAM. So If you want to read more about the BIOS and actually understand more about it and how it works and how ROM works in relation to RAM, I highly suggest you take a look at the second book that I'm using as a reference, and that's Upgrading and Repairing PCs, the 22nd edition by Scott Moeller. I displayed that at the beginning of this video, and I have in the last couple of videos I've made. So I highly suggest that you check out that book. And the chapter that focuses on the BIOS and telling you more about how ROM and RAM work together for the BIOS and how all the processes work, and it confirms for you that separate chips for CMOS and the BIOS is chapter 5 of that book. So check out chapter 5 again in the Upgrading and Repairing PCs 22nd edition by Scott Moeller, and that's published by Q Publishing. You can get that book on Safari Books Online. You can also find it at Barnes & Noble. It's a staple of the industry. You can find it dang near anywhere. So we're going to go, I'm going to use my right arrow to get me over to Advanced, and under Advanced you see that I have processor specifications. I don't have a whole lot of changes I can make here because, again, this is a virtual machine, so my changes here are going to be somewhat limited. I can say that on the installed OS, whether it's Windows 95 or other, it's going to be other. If you're still using Windows 95, it's time to upgrade. If you have a customer using Windows 95, it's time to upgrade. Okay, so that's always going to be your answer. Anything, I would say anything older than Windows 7, it's time to upgrade. Okay, what's also nice is, and I can't use my arrow to kind of show you this, maybe I can use my finger to point at it. Not quite. I would have to use my finger and probably move the screen over. But anyway, under item specific help, that's what's really nice about this version of the Phoenix BIOS, which is the second version that you saw. And that is that it does try to explain to you what each selection is. For example, in this one, select the operating system installed on your system, which you will use most commonly. An incorrect setting can cause some operating systems to display unexpected behavior. So it does try to guide you in some way, and you'll see that changes with the selection of items that we have. We got IO device configuration here. So again, virtual machine, so there's not a whole lot of selections here, but you get the idea here. There's a whole bunch of options, and they're basically all formatted the same. So here we have boot sequence. I can change whether I want to use movable devices. If I look down in the footer or the bottom of the screen, you'll see that if I want to change a value, for example, if I want to make removable devices the second item to boot rather than the hard drive, what I can do is I can use the plus minus. So if I hit minus, it'll move it down in the list. I can continue to move it further down. I go up, select network boot from Intel, which is the virtual NIC that this virtual machine is using. I hit the plus sign. I can move it up. I can move anything anywhere I want just using the plus and minus keys. Okay. And then when I go to exit, here's our famous settings again. We have exit saving settings. Obviously, when you exit saving settings, it's going to save the settings that you changed. So the changes I made, if this were an actual physical computer, it would save these settings to the CMOS. Okay. Exit discarding changes. Basically, this will revert to the settings as they were when I got into the BIOS. Okay, so if someone changed BIOS settings before me and saved them, those settings still exist and they will not change. Only if I hit load setup defaults will they clear those settings, and only if I hit save settings or exit saving settings will those save items from the previous person be overwritten. Okay. You'll notice that there's 2 save options and there's 2 discard options. The only difference between the 2 is 2 will take you out of the program after hitting them. The other 2 will leave you in. So if I hit save settings here, you'll see that it'll give me a confirmation screen. And if I hit yes, it'll accept it and I'm still in the BIOS. If I want to exit discarding changes, I'll hit that and it'll just exit me out and try to boot. Okay, so that's basic BIOS. Again, if you need to know more about those areas and get a better feel on them, you can go back to the beginning of the video and pause on the screens I went through, because I literally displayed every screen that I could find to give you a full depiction of the BIOS. The only other way that you're going to really get to know the BIOS is by getting, as I said, a secondhand computer or something that you can mess with, where you can get into the BIOS and play with it. I, again, highly suggest that anytime that you can put your hands on a computer and play around with it, you do that, because it's the best way to learn. Next, I'm going to show you how I flashed my computer. I did this on a cell phone video just because I'm doing all this stuff out of my pocket, so I don't exactly have the funds to do a lot of the more advanced stuff, but I will go through that video and show you how to flash the BIOS, and I show you some of the UEFI subsystem on my computer, and that will be the end of this video. So before I move on to the video of me flashing the BIOS on my system, I thought I'd take you through the process of actually obtaining the latest BIOS firmware from the motherboard manufacturer of your motherboard on your system. In this example, I'm going to use my current system that I'm operating off of, as well as my current motherboard. So I'm going to take us through obtaining the BIOS from my motherboard's manufacturer. Just know that this process is pretty much the same for most manufacturers. Some BIOS updates will be installed through the UEFI interface, like mine, and some won't. It's very important that you read the manufacturer's manual or user manual for your motherboard or your computer to find out how to properly flash the BIOS of your system. It really breaks down to read the flippin' manual. Most people don't, and they get lost, and they cause their own problems. If they would just read the manual, they'd be okay. So now you may be saying to yourself, well, I got a computer, but I don't have the manual. 9 times out of 10, you can get the manual for your motherboard straight from the manufacturer on their website for free without any issue. And I'll show you how I do that with my motherboard's manufacturer. So again, we're going to do this from the perspective of sitting in front of a customer. You're not quite familiar with their system, and so you need to identify the components in the system before you can move forward. You've already done troubleshooting and diagnostics and discovered that one of the issues on their system is easily solved by updating the BIOS on their system. So what you're going to do is I've identified a tool that is used by a lot of technicians, and it's called CPU-Z by CPUID. This is a free piece of software. If you're using it for financial purposes, obviously you'll want to pay for this software. It's only right. However, for personal use, it's free. And you'll see here I've started it up already, and the reason why I've pre-started up before recording this video is I found that there's a little issue that you need when you start up this program. You need to right click on the icon and run as administrator. It will throw an error if you don't do that process. So I'm running Windows 10, and when I start up the program, it does kick off what's called user account control, or UAC. And that seems to cause a little bit of a problem with this. So I've worked past that before starting up this video, and so just be aware of that. Anyway, you'll see this program is very good at identifying the components on your computer. For example, the CPU tab will identify the processor I have in my system. It'll tell me everything I need to know about that processor. You'll see that I have it slightly overclocked. Because it goes above the rated 4.0 gigahertz that it's been labeled as. But the tab that we need to pay attention to right now, again, we'll come back to this program multiple times throughout the course, but the tab that we need to go on now is the mainboard tab. Don't get confused. Mainboard and motherboard are the same thing. You'll see mainboard tab here, but right here it also calls it motherboard here. Same thing. Apples and apples and apples here. There's no real difference. More politically correct, I guess you could say. No gender denomination to that, or gender call out to that, I guess. Anyway, the manufacturer of my motherboard is ASUS Computer Inc. The model of motherboard I'm using is the Maximus 8 formula, and it's the reversion 1, so it's the initial version that they produced. And I don't believe for this motherboard they produced another one, but it's important that you know this, what version of the motherboard you have, because sometimes they'll produce like 2 or 3 versions of the same type of motherboard, and they'll produce different BIOS firmware updates for those different versions. So I've seen a coworker do this before, where they looked up the model of the motherboard, and when they went to the manufacturer's website, they downloaded the BIOS for the same model of motherboard, but the BIOS was actually for version 3, and he was working on a version 1. And the problem with that is they are different BIOS versions, and he loaded the version 3 onto the version 1, and it bricked the motherboard. Again, bricking means making the motherboard useless. So be very careful of that. Make sure that you know this information. And typically on the motherboard manufacturer's website, they will identify what's for what. I've already done the pre-research. I know that my motherboard is the only version that was actually produced in this model. So the BIOS that I have on my system, I called it earlier in the video. I said that you had Phoenix BIOS, American BIOS, and then you had AM BIOS. When I said AM BIOS, I was referring to American Magnetrons. AM BIOS and American Magnetrons, same thing. And the current version I'm running is the latest version, obviously because I've already made a video on flashing the BIOS, and that's version 3401, and it was published on January 25th of 2017. So all this information is important, especially when you're going to get the latest update. This is, by having this information, you know whether you have the latest or you're behind on a version. When I flashed the BIOS on my system, and you'll see it later in the video, I was actually 2 or 3 versions out from the current BIOS when I did the process. So getting the BIOS firmware update from my manufacturer is pretty easy. Go to Google, and I've done the search already, so I'm going to type in ASUS, and you'll see there it is, ASUS Formula 8 drivers. I'll click on that, and it will give me results. and there's my motherboard right there. I make sure that I'm going actually to the motherboard manufacturer's website, not some malicious site that's imposing that they are my manufacturer, but not. So I verified that. It's going to take me straight to the information for my motherboard. That's my actual motherboard I have in my system. And under drivers and tools is typically where you'll find your BIOS software. And here, since I'm updating through the UEFI system, the OS is not really important on the selection here, but I'm going to go ahead and select my operating system I am using, and you'll see that under that I have a sub selection for BIOS. Now, looking at this, you'll see that there, in fact, is the latest version, which I have currently on my motherboard. But right below that, you see a beta version. I'm going to call this out because I think you need to be very careful on ever using a beta version of a BIOS, because beta versions are pre-release versions of BIOSes, and a lot of times they're not fully tested. So you need to be very careful on using a beta version. The only time I would really use a beta version is if you're on the phone with support from the motherboard manufacturer, and for some reason there's a fix in the beta version that they're telling you that you need to load that onto the system to fix your current problem. But that's very rare, and I would be very careful and stay as far away from beta versions as I could possibly get, especially when it comes to your BIOS. On software, you can get away with it a little bit more, but on the BIOS, be very careful. You'll see in my video, I actually, when I flashed my BIOS, I was at version 1902, and then I flashed it all the way to version 3401. Now, typically you do not have to step upgrade. Step upgrade is when you go to update like software or a program, and basically what you do is you download one, you upgrade, you go to the next one, you upgrade, you go to the next one, you upgrade, and you would only do that if you're like, oh, this is the latest edition 1902, but I'm down here at 0208. With the BIOS, you don't need a step upgrade. So if you're at 0208 and you need to get to 1902, you don't have to load all these other versions in. You just have to download the latest version and load that, because again, when you flash the BIOS and the UEFI system or interface on your computer, it is literally erasing the BIOS completely, or the ROM, the EEPROM chip. It's erasing that EEPROM chip completely before it actually writes the new program onto the chip. So no remnants of these previous versions will exist on the chip when it goes to write the newest version. So don't ever think that you have to step upgrade. You can literally, I could be at the oldest version, 0208, and go straight up to 3401 and load it and be just fine. I've never seen a motherboard where you have to step upgrade, because again, it erases the whole EEPROM chip before it actually writes the new program to the EEPROM. So don't fear that too much. So to download this latest version, I would just click on the global link, and you'll see that it downloads here, and it downloads as a zip file. I've downloaded this previously. I know it's not that big of a file, and you'll see that it'll download pretty quickly. And once it's downloaded, I can actually click on it and go into it and open the zip. What you'll want to do is you'll want to copy the file inside of the zip to in my case, a USB thumb drive so that I can flash my computer with this BIOS update. Do not try to transfer the zip. You transfer the zip, the computer or the UEFI system will not be able to read it. So what you actually have to do on newer operating systems, they're able to read zip files anyway. What you'll have to do is actually go into the zip file and copy that file out to like a USB drive. Okay, and so that's what I did in this case. And the next video section you'll see is me actually flashing the BIOS from a USB drive. So the last thing I'm going to show you in this section is how to get the user manual. The user manual for my motherboard is pretty easy to find. You just go up across these tabs here, manual and document, and you'll see that they offer every version of my user manual that's possible. I can get the German French version. Obviously I speak English, so I can click that here and you'll see it opens right into it. So don't ever hesitate to get the user manual and understand what's on your motherboard. What's really cool about this is, and you'll see in the next chapter's video, is you get even a motherboard layout. It'll tell you exactly where your BIOS is. It'll tell you, like my BIOS is right here. It'll tell you where the BIOS is, it'll tell you where your chipset is, and so on and so forth. And that's all important information to know. So yeah, always keep your manual, and if you for some reason threw it in the trash, don't hesitate to go to the motherboard manufacturer's website and download the latest version. Now I've restarted my computer and we're going to get ready to jump into BIOS. Right now my computer is completing the post process. You will see the post completes with, there you go, with the logo that pops up. It's kind of useless to hit delete or F2 at that screen because we're still going through the process. The second screen is where I'm going to hit delete and F2. I'll mash the keys to get into the BIOS. Once you see me in the BIOS, my BIOS starts on the Extreme Tweaker, so I'm going to navigate to main. And at the very main screen of my UEFI system, you'll see that I can identify what version of the BIOS is currently residing on my motherboard, as well as what version motherboard I have and such. I can also go down to the bottom here and you can see that I have my processor and RAM. I scroll around a little bit here and take you into my favorites just to show you some of the settings that you can set within the UEFI system. Also, you're going to want to go through these settings to actually notate before you flash the BIOS. So I've gone to the Tool tab of my UEFI system and I'm getting ready to flash the BIOS. So I'm going to click on Easy Flash Update and I'm going to tell it that I got USB storage. There you see our BIOS. I've selected it and now I'm going to hit yes that I want to read the file. So what it's doing here is it's reading the file and making sure that that is the version I want to actually install on my BIOS. Once I am happy with this selection, I'll hit OK or continue, and you'll see that it immediately starts processing. So what this is doing now is this is actually prepping the EEPROM chip to accept the BIOS. Now the reason why I can do this, why my system is booted and don't have to worry about losing any information, is because the BIOS itself is actually at this point loaded into RAM. So while this UEFI tool for flashing the BIOS is doing its job, it can erase the EEPROM chip and prep it for the new BIOS. And unfortunately with this tool, it only says processing. It doesn't really tell you what it's doing in the background. But right now you can assume that it's erased or flashed the EEPROM chip that the BIOS exists on. And during this process, it's also going to write the new BIOS program to the EEPROM chip thereby updating your BIOS. So once this process is completed, we'll actually see this version here go from 2202 to 3401, which is the latest BIOS update and is the one that we're actually installing, as you see here. I'm going to fast forward through this video and get us further along so we can actually move along and finish this video. So now the BIOS is successfully flashed to the system. The only option I'm going to have is to reset. At this point, I can't do anything else but reset. You'll see that my computer will complete post, and it'll basically tell us that it's still updating the firmware to the BIOS, and then it'll restart again on its own. So my computer is now completed post. Now you see that message I told you would see, that the BIOS is updating. This will take a second, and once it's updated, it will restart again on its own, and it will basically display a whole bunch of errors. One of the things I want you to notice when this boots up is, unlike before when it went through the BIOS boot process here, it will not actually go to my RAID's configuration readout. It will actually show the hard drives on the main screen here, and it'll tell me that I have to do setups within the system. And the reason why is sometimes it will shut down the RAID pointer just so that you can actually make sure that the BIOS loaded correctly. So I'll have to go through and actually reset the settings for my RAID. Now the information that's in my disk RAID will not be lost. I just have to, again, the RAID has its own BIOS, so all I have to do is point my BIOS to that existing RAID. Again, I will not lose any of my information, but as you see here, some of the settings have changed. I'm just kind of going through and confirming some things real quick here. You'll notice some of my RAM frequencies and stuff have been changed. And here on the main screen, you'll see that my BIOS has in fact been updated to 3401, and the build date for the BIOS has been updated as well. And that's basically it. That's really all it takes to update your BIOS. Just be aware that you will typically have to go into your BIOS and redo a lot of your settings. But that's it. So this concludes my video on the second chapter, which is on BIOS and the UEFI system. If you have any questions, again, feel free to leave them in the comment section of this video, and I'll be more than happy to answer the questions for you. I do plan on in the future having live chats or something like that to answer questions and help people out. If you have any suggestions, please feel free to also include those in the comments below. If this is the first video you've seen of mine, go ahead and check out my previous video where I cover chapter 1. The next video I produce, and I'll be publishing that in about 3 to 4 days, will be based on chapter 3, and that covers motherboards. So I hope you have a good evening, and thank you very much for joining me.